Alright, so let me just show off what we're going to be creating today. So everything about our camera is like we remember it, follows our player, except this time we actually have a smoothing, a bit of smoothing added to it. So we can rotate the camera, move our character, and it just rotates back. Like that. We also have a set of options here to give us a little bit more control over how our camera adjusts. So we can change the adjustment speed. So let's turn that way down. Now it's super slow or super quick. The mid-range is about 1, and it goes from 0.25 to 1.75. And then we also have some options for how the axes adjust, and then also whether actually we want any adjustment at all. So we have only while moving, which is what I've been showing you, only horizontal while moving, which is the exact same thing, except the tilt doesn't change. Always adjust is basically the exact same idea, but it just does it always. And then never adjust is basically just you can turn, rotate the camera, and it doesn't matter, it's just never going to adjust. But if we try to steer, it steers in the direction of the camera. This works in all of the modes except for, I guess, always adjust, because like you kind of have to fight with it in order to get it to work. But for example, only horizontal while moving, the steer will basically reset the character forward to the forward direction of the camera. So yeah, that's the basis of what we're going to be creating. One last thing before we get started. I've actually been doing this for a couple episodes now. Basically what I've been doing is I've been taking the project files from the previous episode, and I've been packaging them in like zip files and putting them up on like a file sharing website. The links are usually in the description, so if you wanted to compare like what you did with the previous episode with what I have for the previous episode, you can just download those files and check them up. You can also just use them as a fresh project file, like you're starting from where I'm starting from, and that's pretty much it. Be sure to check that out. I'm gonna have to do that retroactively for some episodes just because I never really kept the project files past like I can't remember episode 4 or something like that, but that shouldn't be too difficult to do, and it might be fun to do my own tutorials again. Kind of put me in the right head state to do the next episode or something. So that's there, and that's going to be in the episodes from now on. Alright, so I'm going to stop rambling and let's just get right into it. So we're going to open up the camera controller script, and inside here, right at the bottom, right below camera state, we're going to create a new public enum called camera move state. And we're going to have 4. So the first one is going to be only while moving. The second one is going to be only horizontal while moving. The third one is going to be always adjust. And the last one is going to be never adjust. Alright, so let's take the camera move state and let's pop it up here. Right below cam state, I'm just going to create a new category called options, and we will create a new public camera move state. We'll call it cam moves state, and we'll set it equal to camera move state dot only while moving by default. So this is where we're going to be creating our options variables. We're going to have like a camera adjust speed, and then also I think water collisions as well, but for now we'll just deal with this. So now we need to actually set up our switch statement here in the late update right before camera transforms. And this is going to be switch cam move state. We're going to start with case camera move state dot only while moving break. And then I'm going to copy paste this 3 times. And we'll just change this to only while horizontal, always adjust, and never adjust. So let's just start breaking down the enum that we created. So the enum basically represents an interface option for the camera that is basically just a camera following style. And what we have here is only horizontal when moving, only when moving, always adjust camera, and never adjust camera. And since we're working on never adjust camera, let's start by breaking that one down. So essentially, when we run around, it follows our character. It rotates with our character. But when we rotate it, it stays locked at that rotation. It's never going to reset back to the center. In order to actually reset, you have to steer or steer auto run basically. And what that actually does is that instead of resetting it behind the character, it actually turns the character to the forward direction, to face the same forward direction as the camera, like this. And that's basically it. So that's all we have to recreate. Alright, so I'm just going to minimize the camera inputs. And right above camera transforms, I'm going to create a new method, void camera never adjust. And that's what we're going to start with. So let's just come back here. And I'm going to change the camera move state to never adjust for the time being. And so we can start building. I'm just going to put this inside the never adjust. And I'm going to copy this switch statement here right at the top of camera transforms and paste it into camera never adjust. I'm actually going to create a new variable. So we're going to create a new category for them, and we'll call this camera smoothing. And the new variable is going to be it's going to be a float, and it'll be pan angle. And essentially, we're just going to set it at the top of late update. So it'll just be pan angle is equal to vector3 dot signed angle. So this is going to give us an angle that's positive or negative up to 180 degrees. And then the from angle is going to be transform dot forward. The to vector is going to be player dot transform dot forward. And the axis that we want it to be sort of rotating on is the up axis, so it's just going to be vector3 dot up. So this is kind of just going to get the positive or negative angle from the forward direction of the player to the forward direction of the camera. Alright, so let's also set up another variable here right next to pan angle. We're just going to create pan offset. And this is the one that's important for our never adjust, because inside of our never adjust, we're going to want to be checking while the camera is rotating. We want to be setting up the pan offset and setting it equal to pan angle. And then so it's only going to be checking this while we're manually rotating the camera. And then while we're not, we're going to actually subtract pan offset from player.transform.EulerAngles.y. So what this should do is while we're sort of running around, it should stay right behind us. And then once we rotate it, it should snap back. Why is it snapping back? Right, I need to comment all this out. Forgot about that. Alright, let's try that again. Okay, yeah. So what it should do is when we rotate, it should stay with our player's rotation. But the issue here is that we also kind of want it to follow, like when we start steering, see how our player is rotating, and when we try and strafe, we're actually like moving in like really weird directions. So we need to solve that. And the way we're going to solve that is actually twofold. So first, we're going to open up camera inputs again. And most of what we're going to do is inside here. But let's actually just, in our camera never adjust, separate this out. So we're just going to break that right there. And in here, we're just going to go pan offset is equal to 0 if pan offset is not equal to 0. And then also, we're just going to set current pan equal to player.transform.EulerAngles.y. And then up here, what I want to do is I just want to put this inside brackets, and then I want to set up the sort of forward rotation of the player so that it matches the camera. So what we're going to do is we're going to create a new vector 3. We're going to call this player reset. We're going to set that to player.transform.EulerAngles. And then we're going to say player reset.y is equal to transform.EulerAngles.y. And then we're going to set player.transform.Euler-angles equal to player reset, and that's it. So what should be happening is when we rotate the camera and then we start steering, our player immediately faces the same direction as the camera, and then we can start steering the way we need to. So let's rotate and then steer, and there we go. Perfect. Cool. So that is our never adjust. Alright, so the next one that we're going to have a look at is only horizontal when moving. And basically this is just because we're working on the X resetting. So what this is basically just, it does all the same stuff that we need it to. And when we offset it, right, so we'll offset it high, it stays. But when we start moving, it resets to the back. But it stays up high, or it stays down low, because it doesn't reset vertically. It only resets horizontally. And the same thing applies with the steering, where if we hold down the right mouse button and the left mouse button, it just resets the player to the camera. So now let's actually start setting up our adjustments. So I'm going to create a new void right above camera never adjust, and I'm going to call this one camera X adjust, if I can spell. And inside here, I actually kind of want to do the same thing as this, except this is kind of like, it's just a lot. It's just a lot of stuff to write for something like this. It's much easier if we just go if camera state is not equal to camera state dot camera rotate, then we're going to do stuff. And we'll just throw current pan right here, and then just get rid of this, because we don't need it anymore. See, it's much cleaner. Alright, so essentially what we need to do is we need to reset the camera whenever we need to, actually. So let's take camera X adjust. Let's start putting into here. Let's actually help ourselves determine why we're putting this in here. So the always adjust is obvious. That's it. That's all we have to do there for there. The other two we can only do while the player is moving. So we need to go to our player controls, and we need to reveal a couple of variables. So first I'm just going to take this in inputs. I'm going to take the serialized field and get rid of it. And then I'm going to separate these two so that I can make this one public. That's input normalized. And then also rotation directly below it, I'm making that public. Now these two are going to show up in our inspector, so I'm just going to take this hide from inspector and put it on top of both of them. Now we should be able to access these, and I'm just going to take camera X adjust here. Or no, let's actually just do this one here. So I'm going to go if player dot inputs normalized dot magnitude is not equal to 0, or I guess is greater than 0 is probably better, or player dot rotation is not equal to 0, then we're going to do this. And then it's the exact same thing for only while moving, except we just need to put it inside brackets because we're going to include the camera Y adjust there later. So now let's actually build it. So we need a couple of variables. So the first one is going to be a Boolean, and we're going to call this one cam X adjust. And then we're going to need a couple floats as well. So float rotation cushion, and I'm going to set that equal to 3. I'm actually going to put like a little X right after the, rotation X cushion. That's fine. I'm cool with that. And then we're going to add a rotation speed, and we're going to set that equal to 0. All right, so let's set this up. So first, we want to set our X adjust inside of our camera rotate, and the idea being that first of all, if our cam move state is not equal to camera move state dot never adjust, and cam X adjust is not equal to true, then we want to set cam X adjust equal to true. So this is basically just us saying that if we're not set to never adjust and the camera X adjust is not equal to true, then when we rotate the camera, set it to true. And then inside of our camera X adjust, we basically just need to say if cam x adjust, then we're going to do some stuff here, else we're just going to do the regular stuff. And so what do we actually need to do? Well, what we need to do is we need to smoothly rotate the camera back to its 0 position. And so let's just do that really quickly right here. We'll just go pan, current pan is equal to mathf.lerp. The first variable is going to be current pan. The second variable is going to be current pan plus pan angle. And then the time float is basically just like an interpolation between those two floats. Let's just set it to like 0.1 just to demonstrate what it does. And essentially what that's just going to do is it's going to take this, think about it like this. This variable is your starting position. This variable is your ending position, right? And this variable is how far from 0 to 1 you are to your ending position. So that's what's going to happen. It's going to every single frame set current pan equal to 1% of the distance, 10% of the distance between these two variables. So let's actually see what that looks like. Let's switch this to only while moving. Actually, let's switch this to only horizontal while moving. And it starts out normal, and then when we rotate and start moving, alright, so here's our first issue. As you can see, our player is, like, I mean, it looks good, don't get me wrong. Our player starts to rotate, and then our camera tries to follow, and it looks good, but it's not what we want to do, right? We want our camera to be locked behind our player when it's at the 0 position, and we don't want our player leading the camera's rotation. So that's why we created this variable here, the rotation x cushion. Essentially, it's going to say that this is the minimum angle that the rotation needs to be before we reset our cam x adjust and send it back to just this normal, like directly locked behind the camera. So if we go here, if pan angle, and since pan angle is a positive or negative, we're actually going to have to do if mathf.abs pan angle. So that's just going to get the angle, but only positive. So even if it's negative, I don't know, like 50 degrees, it's just always going to be positive. So if that's greater than the rotation x cushion, then we're going to do all this. Else, we want to set cam x adjust equal to false. And this variable, this value here, actually, we're just going to change this because, I mean, it looks great, but I want it to sort of ramp up. So I'm just going to go and set up a x rotation. Nope. What did I call it? I called it rotation. Let's go rotation x speed. Okay. Rotation x speed. And it's going to be plus equals time dot delta time. We'll throw in more numbers there to smooth it, like, or to reduce the speed, make it more adjustable. But for now, this is all it's going to be. I'm going to throw that in there. And then up here, I'm just going to say if rotation x speed is not equal to 0, maybe greater than 0. Then we're going to set rotation x speed equal to 0. And that should be us. So let's have a look. Alright, so we're moving around, rotate the camera, and it resets. So there's a little bit of a pop there at the end. Pop right there. And the reason why that is, let me show you this without maximize on play. Serialize these two. So essentially, when we look at pan angle, I think this has to do with the fact that the camera is sort of moving slightly behind the player. So, and I obviously don't mean physically, I just mean like in time. So you can see here, it goes from like 1 to -1, the rotation. So the lower the cushion is, the more likelihood you have for having issues with the sort of reset. And so that's why there's that pop there. I figure like it's fast enough that it doesn't register. But I mean, honestly, that's just the best way I've figured out how to do it. Like if someone else has a better way of doing it, please do let me know, because I kind of would like for it to be much smoother, but that's about as good as it gets in my opinion. All right, let's switch this to only while moving. And let's actually start on our last one. And before we start creating variables, let me just show you what we need. Alright, so the next one is only when moving. And that one is basically the same as only horizontal when moving, except, of course, the vertical changes. And the vertical changes actually kind of slowly, so clearly I have to make some changes. But, well, this is future me saying this, because past me is about to speak and show you how I did that. Probably just change it all in the end or whatever, but that's basically how it works. And all of the same rules apply, so if we sort of rotate it like here, and then do the steer thing, it just does it. Alright, so now that we know, let's create a new variable called camYadjust. Capitalize that A. Let's do the exact same thing that we did in camera inputs, except instead of in here, we basically want to do it inside camera none. And the reason why we're not putting in camera rotate or camera steer is because steer is basically the X locked down, but the Y can still move, right? The tilt, that is. So inside camera none, so we're going to go if not camYadjust, and inside brackets we're going to go camMoveState is equal to cameraMoveState dot always adjust, or camMoveState is equal to cameraMoveState dot only while moving. And then we're just going to set camYadjust equal to true. And actually I'm just going to make this change here to just put the camYadjust right at the beginning of the if statement. So let's create our camYadjust, and let's do that right below camera xAdjust. So void camera yAdjust, and it's basically going to be this. So if the camera state is equal to camera state dot camera none, or actually I guess we can just throw this one in here, because it pretty much should always be working. So first of all, let's get rid of this because we actually don't need this at all. Then inside brackets, we're just going to go if camYadjust brackets else, and then we'll just stop there, I guess. Actually, let's just hold off on the else for now. So yeah, we're going to create a couple variables, and basically it just follows the same rules as we laid out. Instead of a rotation cushion, we're just going to have a minimum and a max. So this is going to be yrotmin is equal to 0, yrotmax is equal to 20, let's say. And then we're just going to have a rotation y speed. We're going to set that equal to 0. And then basically, yeah, it's just the exact same as all this. So there's going to be a rotation y speed plus equals time.delta time. And I'm actually going to divide this one by 2, just because I want it to be half the time of this. And then I'm going to go if current tilt is greater than y rotation max. And let's actually do greater than or equal to, or current tilt is less than or equal to y rotation min. Then we're going to do our current tilt is equal to mathf.lerp current tilt, and then instead of doing current tilt plus or minus anything, I'm actually going to take y rotation max and divide it by 2. So it's going to be 10, but the basic idea is that since y rotation minimum is always going to be 0, then we can just divide the y rotation max to get the camera moving towards the center of the minimum and the maximum. And then the speed is going to be rotation y speed, of course. Then we're going to else if current tilt is less than y rotation max and current tilt is greater than y rotation min. Then we're going to set camYadjust equal to true, false. And then here we'll just go else if rotation y speed is greater than 0. Then we'll set the rotation y speed equal to 0. And then let's take the camera Y adjust, let's paste it into here, and also always adjust. Let's test that out. Alright, so nice. So essentially, the way it should work is that the camera should just stop right between those two. And I think right here we're running into an issue where it's trying to reset for some reason. So let's solve that. So yeah, equal to camera none is correct. I had it right the first time, so let's just leave it there. Cool. So now let's change it to always adjust and let's see. So it's basically always just going to reset regardless. Okay, now let's set up the sort of speed variable. The plan is to create a new option here. We'll go public float. And what I'm thinking is that we're going to go between probably like half speed. We'll just go between half speed. So let's go camera adjust speed. We'll set it equal to 1. And we'll go between half speed. So let's go between, so range, go between 0.5f and I guess 1.5f should do. So let's take our camera adjustment speed and right down to here. We'll go times camera adjust speed, and then same thing here. We'll go times camera adjust speed, and I'm actually just going to put this inside brackets just so that we know we're multiplying this. Alright, so 1, oops, always adjust. 1 is our normal speed, looks good. Half speed, could be better. And then 1.5. Okay, 1.5 is definitely pretty damn different. But you can really notice that pop at half. Right around 1. It's pretty good. Okay, maybe we'll just adjust the range 2.5 and 7.5. So there's a greater distance between the two. Let's bring it way down. And then way up. Cool. So I'm happy with that. I'm actually really happy with that. And I think we got a lot of really good work done today. So yeah. Cool. Now, I do want to point something out. I had this episode recorded before I even got this comment, but someone commented on one of my videos saying that the player movement is kind of screwed up, that whenever you strafe, you kind of move forward a bit. And this is actually kind of interesting because I didn't even realize it, but let me just try and get right in. Okay, so you can see the player is perfectly lined up, and if I strafe, oh, that's not strafing, that's rotating. If I strafe, I moved a bit forward, and then I just keep moving a bit forward. And what I think is happening is you can see the forward direction that we have the normal setup. You can actually see it. You can actually see it sort of resetting. And what I think is happening here is I think that the character actually starts moving before we change the forward direction. So it moves slightly forward, and then it starts strafing. So I'm probably going to have to figure this out and set it up for the next episode, and then we'll just have to fix it next time. It's not a huge issue, but I'm happy someone pointed it out. And I'm always open to criticism, always open to, you know, people pointing out some problems or errors in the codes that I'm working on. I even see it myself. So just, you know, don't be afraid to post something. I'm happy to receive it. Obviously, if you're being rude, maybe I'll pay attention to you, maybe I won't. I always have that choice. But we're all here to sort of figure it out together, and I'm very happy to sort of accept that. So I'll probably be fixing that in the next episode, and I'm not really sure how long it'll take in the episode. Hopefully not the whole thing, but if it does, you know what, that's fine. I'm okay with that. And after that, I think I'll get onto the sort of collisions, the camera collisions, because there's a lot of really interesting stuff to dig into there. Yeah, it took a long time to finish this episode just because it's a lot to cover, and I kind of wanted to make sure I was covering it right. On top of that, I'm sure I gave you guys a warning at the beginning of the episode, but I'm sure you heard the rattling fan that I'm replacing soon. That shouldn't be in the next episode, but I mean, there's nothing I could do about it. Like it just rattles. Anyways, thanks again for watching, and I'll see you next time.
Super trooper, super trooper, super trooper, and he sells soup.